All right, you guys, today we are looking at triangles. And first up, we're looking at how do we classify based on sides. So we have a few options. So first up, we see equilateral triangles have 3 congruent sides. Isosceles triangles have 2 congruent sides, but I'm actually going to add to that, and I'm going to say it's not just 2, it's really at least 2 congruent sides. So isosceles is at least 2 congruent sides, and scaling we have no congruent sides. So off to the side here, I'm showing you a little Venn diagram of how isosceles triangles and equilateral triangles are related. So we can see that over here, this isosceles triangle here, this represents the set of all isosceles triangles, and we can see that our equilaterals are just a subgroup within. So another thing that I could just add right here is that equilateral triangles are also isosceles. So it just goes back to that definition. Isosceles is not just exactly 2, it's at least 2 congruent sides. So any equilateral triangle that has 3 congruent sides would also be considered to be isosceles. Okay, we also classify by angles. So if we have 3 congruent angles like so, that's equiangular. If we have 2 congruent angles, at least 2, right, has to be isosceles. If a triangle has 3 acute angles, so all angles are less than 90 degrees, it's acute. If we see 1 right angle, it's right. If we see 1 obtuse angle, so 1 angle that is more than 90, less than 180, then it is obtuse. Okay, one other thing to point out since we're talking about triangles, let me put a little star to the side. If I'm looking at an equilateral triangle, for example, so any equilateral triangle, all sides are the same. They are also equiangular. So any equilateral triangle that we see, all sides are congruent. Also equiangular, all angles are congruent as well. All right, next I'm just helping you to visualize all the different possible triangle configurations. I found this super cool visual, so I wanted to share that with you. So it shows you, for example, equilateral and acute. So here all of the sides are the same. All of the angles would have to be the same as well. They all have to be 60. And what's nice about this image is that it's drawing the triangle just like the side lengths would have to be, just like the angles would have to be. So if you're interested, just go through and just try to see all the different configurations. Over to the right, I'm looking at interior and exterior angles in a triangle. So interior, pretty self-explanatory. These 3 would be interior. If I extend any side, so for example, if I extend this side, I'm creating an exterior angle here, but I could have extended this side right here and got another exterior angle here. So an exterior angle is formed just by extending a side of a triangle. And what ends up happening, let me just draw it a little bit more simplified. Let's say that I'm looking at this triangle and I extend this side. Here is an interior angle, here is an exterior angle. You can see that they form a linear pair, so they have to have a supplementary relationship. Right, which just means that they add to 180. All right, next I'm saying let's put the sides in descending order. So I'm looking at a triangle here. I'm only giving you the angles, and I want to put the sides in descending order. So before I get to this example, I actually pulled another visual here. So here is a triangle. So looking at this triangle, let me pull my notes out from the back. Okay, so looking at this triangle. So if I look at, here's my smallest angle, 40 degrees. It is opposite my smallest side right here. My middle angle right here is opposite my middle side right here. My biggest angle, the right angle, 90 degrees, is opposite my biggest side right here. So you can see that opposite a small angle is your smallest side. Opposite your biggest angle is your biggest side. So if I go back to my problem, if I want to put my sides in descending order, let me zoom in a little bit more too. So descending order, that is decreasing order. That is saying big to small. So I'm looking at what's my biggest angle. So right here. So opposite must be my biggest side. So BX. My middle angle must be this angle right here, angle X, 60 degrees. So this must be my middle side, BO. And then my smallest angle, angle B, here must be my smallest side, OX. So descending order is decreasing order, right? Biggest down to smallest. Okay, in example 2, I'm saying, okay, now I'm giving you all the sides. Let's put the interior angles in ascending order. So ascending is increasing. So I'm looking at small to big. So I'm looking at, well, what's my smallest side right here? So it's opposite right here, my smallest angle, angle R. Okay, where's my middle side? Right here, 5. So it's opposite this angle C. And then my largest side here, opposite my largest angle, angle A. So again, if I just go back to that original thing that I said, back to here, right here is my smallest angle, it's opposite my smallest side. Here's my largest angle, it's opposite my largest side. Okay, next up we're looking at the triangle inequality theorem. So I'm picturing A, B, and C are all sides of a triangle. But as I first present this, I want you to imagine that we only know two sides. Imagine that we only know A and B. We don't know C. C is our third side. So C is our third side. So how would it relate to the other two sides? So I'm going to tell you the rule first, and then I'm going to show it to you with an example. So that third side, C, it has to be greater than the difference of the two known sides, and at the same time it has to be less than the sum of the two known sides. So I'm going to give you an example. I'll pull my sheet away just for a moment, but I'm going to assume that we are given a side that is 5 and a side that is 9. So I want you to imagine a side of 5 and 9. Okay, let me take 2 strips of paper. Let me pull this away for just a moment. So I have a side that's 9 and a side that is 5. So I have 2 known sides. And I'm trying to picture, well, what spread of values could my third side be? So I'm going to imagine that these two sides are going to create a triangle. So I'm going to connect these two sides right here. So I'm going to keep my finger right there. And I'm going to close it down to here. So what I can see is the difference between them would be 4 units. So if that third side was 4 units right here, I would just have a straight pathway. I would not have a triangle. But if I open this up a little bit, so the angle right here, like a little bit more than 0 degrees, I can connect here and make a side. I can make a side that's just over 4 centimeters. Okay, this angle is getting bigger, bigger, bigger as I open, right? So here I can see, okay, here could be that third side again. Let me keep rotating, making that angle bigger, bigger, bigger. Here's that third side again. Okay, keep rotating until I get to this other extreme way down here, which would be the sum of the two known sides. So what I've done is I've really made the angle where my finger was, I made it go from 0 to 180 degrees. So right here, right where it was the difference, I would have a straight pathway, and I can open it up, connect, make a triangle, all the way up until I get to this other extreme where I'm back to a straight pathway. So I can see that my third side has to be greater than the difference, but less than the sum of the two known sides. At those two extremes, we're back at a straight pathway. So right here, it could be just a little bit more than 4, but at the same time, just a little less than 14. All right, let me transfer that to my paper. So that third side has to be greater than the difference, but less than the sum. So when I'm taking the difference, it always has to be the big one minus that smaller one. So I'm getting that C has to be more than 4, but less than 14. So this is just an inequality notation. Okay, all it reads as is greater than 4. Right, greater than the difference, but less than the sum. Our sum here was 14, and that's of the two known sides. All right, there's two things that we take from the triangle inequality theorem. We ask two types of questions. So here is the first one, example 3. So which of the following are possible side lengths of a triangle? State possible or not possible. So here, what I'm taking from the theorem is I'm taking this part of it right here. I only have to pay attention to this part of it. So C less than A plus B. And C, I'm focusing on as my largest side. All right, so I'm saying, well, the largest side has to be less than the sum of the two other known sides. So my largest side is 25 here. Here it's 22. And here it's 19. So I'm focusing on that as my C. So is 25, is it less than 8 plus 14? Is 25 less than 22? Right? Absolutely not. This is false. So this triangle is not possible. Let's say that I want to visualize it, right? So much of geometry is just so much visualization. So if I picture my biggest side as 25, if I have two sides that are 8 and 14, I can see that those sides are not even going to connect to make a triangle at all, right? 25 is just too big, right? It blocks us from creating a triangle. Okay, if I look at my second one in B, I'm saying, well, what if I have 8, 14, and 22? Does that make a triangle? So is 22 less than 8 plus 14? Is 22 less than itself? No, it's equal to itself. So this is again false, which means that this is not possible. And if I visualize it, here's my biggest side, 22. If I have a side that's 8 and 14, it's making me that straight pathway. That's not a triangle. That's not possible. Okay, my last variation, clearly I got to give you one that works. So how does 19 relate? Is 19 less than 8 plus 14? Is 19 less than 22? And yes, finally we see success. This one is true. This would create a possible triangle. And if I make a little sketch, here's my biggest side, 19. Here's my 8. Here is my 14. And finally, I have a triangle. So I want to make sure that my largest side is less than the sum of the two known sides. All right, next up. What range of values can a triangle with the following sides have for its third side? So here I'm really doing exactly what I did up above right here. So I know two sides. What spread of values could the third side take? So I know that C has to be greater than the difference, but less than the sum of the two known sides. So if I know sides are 4 and 10, that third side has to be greater than 10 minus 4, but less than 10 plus 4. So C has to be greater than 6, but less than 14. So if you write it in inequality notation, great, that's what it looks like. Some of you may want to write interval notation, and that would be 6 to 14 in parentheses. That would be fine also. Okay, if I tell you that two sides are 4, C has to be greater than the difference, but less than the sum. So C has to be more than 0, but less than 8. Okay, or 0 to 8, just like that. Okay, one other thing just to visualize the two extremes, one strategy, I'll do it with A. So in this one, let's say that I picture my two extremes. So here is the 10, and here is the 4. Okay, so I'm picturing that angle as close to 0 as I can possibly draw it. So I can see that this side right here, C, right, it has to be more than 6. At 6, it will be a straight pathway. The other extreme, so if I have 10, and I try to draw this angle as close to 180, but a little bit below as I can make it, right? So that angle has to be just a smidge below 180. And I can see the other extreme right here, right? That third side has to be just under 14 as well. So it can be between those two extremes, more than 6, but less than 14. All right, next sheet. All right, so we also have Pythagorean inequalities. So here, we've already talked about the Pythagorean theorem. We know that that's a squared plus b squared equals c squared, and it only works for right triangles. So here we're looking at how could we extend it to other types of triangles as well. How could we extend it when the triangle is acute versus obtuse? So in all of these, what I want to focus on is my longest side. So C is the longest side. So I'm just going to shade all of these longest sides in red. So if that's my longest side, I'm really interested in the angle that is opposite. So right here for all three. All right, let me go back and show you just a visualization for a moment with 3 strips of paper. So imagine that I have 2 legs like so, right? That's my A and my B. And then here is my C, here's my hypotenuse. So I know that when it's a right triangle, a squared plus b squared equals c squared. But what happens when it's acute? So when it's acute, this angle right here is going to narrow. It's going to close down more, which means that my c squared value will be less than the sum of a squared plus b squared when it is acute. Okay, and if I make this angle obtuse instead, if I open it up wider like that, then I know that here, my hypotenuse, when it was a right triangle, that c value squared is now going to be greater than the sum of a squared plus b squared. So if I start with that right triangle, c squared was equal to a squared plus b squared. But when it's acute, it's going to be less than, and when it's obtuse, it's going to be greater than instead. Let me write that down. All right, so when it's right, this is a right angle, and c squared would be equal to a squared plus b squared. Okay, when it's acute, c squared will be less than a squared plus b squared. And when it's obtuse, c squared is greater than a squared plus b squared. All right, so next I'm saying, well, here are three sides of a triangle. So I'm guaranteeing that it's a triangle. We don't have to check that it's a triangle first. And then I'm saying, well, let's classify it as acute, right, obtuse, equilateral, isosceles, or scalene. So first off, I know it's isosceles because I see two sides that are the same. So next I need to look at that structure of c squared. How does it relate to a squared plus b squared? So if I went ahead and I plugged in 2 root 5 into my calculator, I just want to know, is that a smaller side or is that a bigger side than 8? So 2 root 5 as an approximation is going to get me 4.5 almost. So it's smaller than 8. 8 is my biggest side. So 8 is my C. So I'm looking at 8 squared. How does that relate to 2 root 5 squared plus 2 root 5 squared? And when I'm squaring a radical, right, it's just looking like 2 times 2 times 5. And this would be the same because it's the same number being squared. So 8 squared is 64. And then here 2 times 2 times 5, I'm at 20. And then another 20. So we know that 64 is obviously greater than 40. And what does that tell us? That tells us that it is obtuse. So this triangle, we knew it was isosceles. We have two congruent sides, and it's obtuse. Okay, let's try it one more time. So here we have three sides given, 6, 12, and 6 root 3. So if I look at 6 root 3 as a decimal approximation, gets me about 10.39. So it's smaller than 12, so 12 is my C. So I'm following that structure, C squared. How does it relate to A squared plus B squared? So here's my 12 squared. Here I'll do 6 squared and 6 root 3 squared. It doesn't matter what we call A and B, they're just our other two sides. So here 12 squared is 144, 6 squared is 36, 6 root 3 squared is like saying 6 times 6 times 3, so 108. All right, well, now we get 144 equals 144. So we know then that it's a right triangle, and all three sides are different, so it's also scalene. So I would say scalene and right. All right, next one up. This is kind of a refresher. We've been doing this one for a while. Can we find perimeter? Can we find area of a triangle? And then the new layer is just, can we classify it? So can we classify it properly? So here, first and foremost, if I look at my picture, I know that to get my perimeter, I need to know what those right triangles are. Because I don't like to use distance formula per se. I like to just visualize it as Pythagorean theorem. Let me get a little tighter. I know it helps every time I have a grid. Okay, so if I'm looking at MA first, right, I'm visualizing this right triangle. I'm going to have to do AP next, so I'll just draw in all those triangles, and then MP as well. All right, so if I'm looking at MA first, big square root, here I have a leg that's 2, so 2 squared, and then 6 squared. So that gets me 4 and 36 under the radical, which is the square root of 40. So if I simplify the square root of 40, that's 4 times 10, so 2 root 10. Okay, AP next. So AP, I have a leg of 2, and I have a leg of 6, so I see it's going to be the same thing, also 2 root 10. MP last. So here we're 4 and 4. So 4 squared plus 4 squared gives me 16 plus 16, or 32. So I should know that that's 2 16s. So 2 times 16, that will end up being 4 root 2. All right, so I know my 3 sides, so my perimeter, I just have to add them. So I have 2 root 10 twice, and 4 root 2. So I can only combine my like terms. So right here, same radicand, that's going to get me 4 root 10 plus 4 root 2. Units. All right, so there's my perimeter. Area next. I know it's a triangle, so I know it's half the base times the height. If it was a right triangle, I could solve for the legs and do 1/2 base times height using the legs. This is not a right triangle because I do not have slopes that are opposite reciprocals. It might look like these ones might be for a moment because we saw the 2 and the 6 both times, but this one has a positive slope, this one has a positive slope, so the slopes are not going to be opposite reciprocals, so it's not a right triangle. I could figure out the area of this rectangle and subtract these 3 triangles. That's a strategy. I could do that. Or I could try to draw in my altitude and solve for it that way. And I think that's probably where we need the most practice. So let me zoom out a little bit and do it that way. So let's say that I make the base PM. So if I make the base PM, I need to know its slope. So the slope was down 4, right 4, so my slope was -1. Let me slide over so you can see all of that. There we go. All right, so the slope was -1. PM had a slope of -1. Down 4, right 4, -1. So I know that the perpendicular slope will be +1, right? Opposite reciprocal. So I need to connect to where A is. So where A is, I'm going to do a slope of 1. So I'm just going to plot myself a bunch of points and then go in this direction as well. So my altitude that I want is that perpendicular segment that connects my base to a vertex. And I saw that this was an isosceles triangle, so that seemed the easiest way to approach it. So right there, that's my altitude. So if I picture that right triangle that connects right here, the base, to A, I can see that it's going right 1, 2, 3, 4, and up 1, 2, 3, 4. I've already seen that pattern. I saw it over here. So I know that it's going to be 4 root 2, right? I've already solved for that. I already know that. So now if I visualize that triangle, let me draw it out like this. I knew that the base was 4 root 2 because I solved for that right here. So MP is 4 root 2. And I know that the altitude right here, it has a measure, the height of 4 root 2. All right, so here my base and my height happen to be the same. So when I go to area, half of base times height, half of 4 root 2 times 4 root 2. So half of 4 times 4 times 2. Half of 4 is 2, times 4 is 8, times 2 is 16. So we get 16 square units. All right, lastly, I just want to classify it. I already know it's isosceles, I just don't know what else. So if I put it in this little spot right here, how does c squared relate to a squared plus b squared? Well, what's my biggest side? Well, if I plug it in, I'll see that 2 root 10 is actually the biggest side. So I have 2 root 10s. So one of them has to go in right here, squared. And then here will be the other one, squared. And then my other side was 4 root 2. So I can already see that this will be less than what's over here because I'm seeing the other 2 root 10. So I actually already know it's isosceles, but I'm just going to work through just to double check. So 2 root 10, 2 times 2 times 10 gets me 40. So this part would be 40 as well. And then 4 times 4 times 2 is 32. So yes, obviously less. 40 will be less than 72. So that tells me that it's isosceles and acute. All right, lastly, I'm going to go over these two theorems. I'm going to prove them with you next week. So this is just a little preview. So triangle sum theorem. So if I have 3 interior angles of a triangle, let me show you with a little tearing of a paper. So here I have 3 angles in a triangle. So if I tear off, say, angle 1 and angle 3, and I rotate here and here, I can see that I have a straight pathway. So it shows me that all of my interior angles, they have to add up to 180 for any triangle because I have a straight angle overall. So over here, I'm just going to write the measure of 1 plus 2 plus 3 will equal 180. So all of the interior angles for any triangle will sum to 180, always. Okay, for my second one, exterior angles theorem. So angle 4 would be my exterior angle. So again, it's just extending a side of a triangle. So in relation to angle 4, 3 would be adjacent to it. So I'm looking at the 2 angles that are not adjacent to angle 4, and that would be 1 and 2. So those 2 angles that are not adjacent, we have a new name for those. We call them remote. These are the remote interior angles. So again, they're the ones that are not adjacent to it. So then I'm picturing, well, what's that relationship? Let me show you with my paper again. So let's say that here's my paper, and I'm just going to extend right here and call that angle 4, just like that. Okay, so I'm going to go ahead, I'm going to tear off my 2 remote interior angles, 1 and 2. Let me get it situated back again like that. And then when I rotate, I see that they are going to take the position of angle 4, just like that. So I see that the 2 remote interior angles, 1 and 2, when I add them up, it's really the same as the measure of angle 4. All right, so let me write that here, and we will prove it more formally when I see you guys next week. So the measure of 1 and 2 is the same as the measure of 4. So when I add up the measure of 1 and 2, that will equal the measure of angle 4. All right, so 2 quick examples, and then we'll call it a day. So here in the first one, we're given 3 interior angles. We want to find x and the measure of angle A. So I know that all of those angles, they have to add to 180, so I can build an equation. So x squared minus 10 plus 5x minus 10 plus 4x plus 10 has to equal 180. So I see it's a quadratic equation. I got to combine my like terms. So quadratic term, my linear terms add to 9x, and my constants, I have a negative 10, all equal to 180. I need to factor. I can't factor till it's equal to 0. So I have to subtract the 180 from both sides. So x squared plus 9x minus 190, all equal to 0. So I'm looking for 2 numbers that multiply to a negative 190, but add to positive 9. So I should come up with 19 and negative 10. So here are my 2 factors. And when I set those factors equal to 0, I get 2 solutions. I get negative 19 and positive 10. Okay, that negative 19, I can see that if I plug it in right here or right here, it's going to give me something negative. You can't have a negative angle measure, so this is extraneous. And if I plug in the 10, right up here, I will get 90 degrees. I'll get 50 degrees and 40 degrees here. So I'm just double checking, does it get me back to 180 total? Absolutely, it does. So x is 10 and the measure of A is 50 degrees. All right, one more example, example 8. So find x and the measure of PRT. So I'm solving for the exterior angle here in the end. And I know that it's going to be the same as these two angles added up. So right now I have these three angle measures given, so I can build an equation. So 7x minus 2 plus 3x minus 5 plus 5x plus 7 equals 180. Okay, combine the linear terms. So I have 7, 3, and 5. I have 15 x's. My constants balance to 0. So I really have 15x equals 180. Divide each side by 15, and I get that x is 12. So x is 12. So if I plug in the 12, so if I'm looking at what is 7 times 12, take away 2, I end up with 82 degrees right here. 3 times 12, and then take away 5, I end up with 31 degrees right here. So I know that when I add the 82 and the 31, that's going to be the same as the exterior angle, 113. So the measure of PRT is 113. I can also double check by finding this last angle and seeing that they form a linear pair. So 5 times 12 would be 60, plus 7 would be 67, and that just confirms it because together they form a linear pair. So the measure of PRT ends up being 113 degrees. All right, that's all I got for today. I'll circle back to it when I see you guys next. Have a good rest of your day.